pointers in Zig. Let's do this. I'm hoping to get through like maybe 40 exercises. That's kind of like the general goal. And again, I don't have chat up, so I can't see chat. So if I mess it up, flip, zoom in. If I mess up and I don't say anything, I'm sorry, okay? All right, hey, check this out. Okay, so foo equals this, and foo is a pointer. I think we already did this one. Yeah, we already did this one. I forgot. Okay, so this is super cool. You can dereference post, right? You don't have to, because you know one of my things that I've always hated is when you have to dereference like this, and you have to do like pointer, and then you have to do the stuff. Oh, I've always hated that. The fact that I don't have to do that, and I can do it right here, and then theoretically you could keep on going. Love it. Absolutely love it. Okay, so let's go to 40. We're going to go to pointers too. It's important to note that variable pointers and constant pointers are different. Okay, yeah. Then foo is of type 8, and bar is a constant. It's a pointer to a constant of U8. Well, that's not a constant pointer, right? That's a pointer to a constant. You can always make a const pointer to a mutable value, but that you can, let's see. Yeah, that's if you do a const beforehand, right? Isn't that like the whole C thing? Isn't it const thing, const this, right? So this would be a constant pointer to a constant. Interesting. All right, so you can always make a const pointer to a mutable value var, but you cannot make a var pointer to an immutable value const. This sounds like a logic puzzle, but it just means that once a data has been declared immutable, you can't coerce it to a mutable type. Okay, that's good. Think of mutable data being volatile or even dangerous. Zig allows you to be more safe and never less safe. Okay, so. Oh, I have to go like that, right? Wait. I have to do that. First try. It's a pointer constant. Okay, so a pointer constant. So in this, a pointer constant is... So you can't adjust pointers, right? Ooh, open cell phone for chat. You little hot dog. Oh, I have like no battery left. Like me, my baby do. All right, here we go. We're going in. I'm going deep. I don't even know how do I see myself? I just want chat. Dude, the mobile app, I swear, I just want to punch the mobile app in the face. This is what they give you for the mobile app. Just give me the effing chat! Oh my goodness. Give me the effing chat. It's broken. It sucks. I suck, you suck. We suck together. Genius UI devs. Just give me... Dude, you can always tell when someone's building a UI for something they don't use, right? Twitch, get product managers who stream and do it well. You know what? I will give you 5 hours a week, $100,000 a year plus health insurance. You got that? You feel me? You and I. 5 hours a week, product manager. Okay? Hey, Twitch, I'm just throwing it out there. Okay? I'm just saying that. Yo, Prime, increase the background volume. Yo, you increase the background volume. All right, let's go to 41. Pointers 3. The tricky part is that pointers immutability, var versus const, refers to the ability to change what the pointer points to, not the ability to change the value at the location. Okay? Const locked. What the? Var unlocked. What the hell is this? Const P1. What is this? Both P1 and P2 point to constant values which cannot change. However, P2 can be changed to point to something else, and P1 cannot. Oh, so this is how you do a... Oh, weird. Okay, this is super strange. Okay, Zig, I think Zig got this wrong. I think Zig got it wrong. Right? Okay. Here's P3 and P4. Both let's see, can both be used to change the value that they point to, but P3 cannot point to anything else. Yes, because it's an unlocked constant, so it's P3 cannot be changed. Okay, so this would be a const pointer. This is a const pointer. This is a variable pointer, but you cannot have Oh, weird. Okay, that's so strange. What do you guys think about that? Makes sense to me somehow. It doesn't make any sense to me because, like, to me, this is how you declare a constant pointer to a constant. Whereas, because, you know, I would never call this a pointer, a const pointer, right? This is a pointer to a constant. Whereas this is a constant pointer to a constant. This is just a pointer to a constant. But it's weird that you can do, what's it called? P1 and P2, but let's see, however, P2 could change. Okay, so what the hell is locked? I'm confused at what locked is. What the hell is locked? Okay, hold on. Let me look at this again. The tricky part is that a pointer's mutability, var versus const, refers to the ability to change what the pointer points to, not the ability to change the value at that location. Correct. So const locked 5, const unlocked. Oh, I see what they're saying. Sorry, I thought this was some sort of keyword. Oh, I'm so stupid. That's just an identifier. Okay, yes. This is the difference between a const pointer to a constant versus just a pointer to a constant. Okay. Psh. Oh, psh. 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 Ow. Wait. This is just a U8, right? Yeah, got it. Okay. Sorry, I was the stupid one there. Locked is just a confusing variable name. I was the stupid. Yeah, I know. Brain no worky. Who's the blonde guy? What? There's a blonde guy. How does this one man have so much energy? We've already talked about it. It's a little bit of that. It's a little bit of that. You know. My wife went and looked up my name, by the way. You sons of bitches. Okay, my wife went and looked up my name because she was curious what people have to say. And guess what? You guys are apparently very positive with all the things you have to say to me, except some of you guys are accusing me of illicit drug usage regularly. Okay, and my wife was not happy about that. Okay, you're a dick. Foul. You're a foul person for doing that. Can you scream that loud? Yeah. I drink a little bit of coffee. I can't help it that I take a little bit of the coffee, a little of that Colombian brown bean. You know what I'm talking about? Dude, stop pissing off my wife and accusing me of such horrible things. Oh, yeah, what is that? What are all those? Yeah. No snacks. Oh. No snacks because I don't want to become. I don't want blood sugar spiking. What is this? Oh, is this deodorant? Yes. Yo, I just got deodorant from a girl, a real one. Have you watched Austin Powers? Austin Powers with the what's it called? With the toothpaste and toothbrush. I get it. Okay, I will use it. That's so funny. Okay, well, I mean, I guess I better put on a little deodorant. Oh, got to make some people happy. Oh. Woo! There we go. I'm literally a smelly nerd apparently. A new guy does it. Yeah, can someone help him? Let me sniff you real quick. Hey, I'm just reporting. Don't forget to deodorize the Gimblies. Woo! That was quite exciting right there. We got it. No more ball smell. Wait. All right. Anyways, now let's use pointers to do something we haven't been. Okay. The real truth. Real truth is apparently someone thinks I stink, and she's a woman, a real one. Now let's use pointers to do something we haven't been able to do before. Pass a value by reference to a function. Why would we wish to pass a pointer to an integer variable? How loud is this, by the way? It's like blasting in my brain. And you guys are only dealing with it that much? Dude, okay, hold on. There we go. I'm going to do that, and then I'm going to turn this up. Yeah. You're loud. You're loud. All right, anyways, let's use pointers to do something we haven't been able to do before. Pass value by reference to a function. We wish to be able to pass a pointer to an integer variable rather than an integer value itself because we are allowed to change the value of the variable. This is what I'd like to refer to as devil programming. Or C, commonly referred to as C programming. So for those that don't know, this is like your classic C conundrum here. What do you do? That. My guess is it does that because that's how you dereference something, right? That's how you dereference it. My guess is that. I'm just gonna guess. It didn't tell me how to do it. I'm an actual genius. I'm an actual genius. By the way, I love this syntax. I'm actually loving the fact that you don't do that. I am loving that. I think that's one of Zig's greatest contributions is these post-fix pointer derefs. Low level learning. Are you doing that? I want to understand and follow through the stream. Where can I check things? Does boot.dev have something about pointers? TJ is actually developing that. You're actually a good programmer. I know. Can you believe that? Actually can program. I can fix her. You can't. Brazil, it's pretty good. It's really good. For anyone that's ever programmed enough about pointers, this is so good because even in Go, you still have to do something like, and then do something with it, right? It's really easy for this, right? Because that's not a big deal. It's once this thing is a struct and you need to get something out of it. Sounds wonderful. Can you fix my printer? Yeah, I could put my bike in your printer if you want that. All right, so let's go to 43. As with integers, you can pass pointers to a struct when you wish to modify that struct. Pointers are also useful when you need to store a reference to a struct. Okay, yes, we've done this a bajillion times. There we go. Let's go. Okay, note that you don't need to dereference PV pointer to access its fields. Nice. I like it. I didn't realize, okay, so this is good. You don't even need to do the post fixing. Let's go. The man. The man, the myth, the legend. Smell auto deref. Let's see. Let's visit our RPG example and make print character function take a character by reference and prints. Let's see, and prints it ands. Prints a linked mentor character if there is one. Ooh, yeah. Look at that mentor character. Oh, my goodness. We got nullable, boys. Boys, we're nullabling. Isn't that cool? That's another thing I like about Zig. You say if the type is nullable. It's a pointer, but this is a pointer that's also null, right? Whereas you can have a pointer that's not null, right? 12 billion mistake incoming. No, it's the opposite. Right? Right? Print character. Print, please pass in Gorp. Oh, hell yeah, Gorp. Glorp. Let's go. Is that your name? Is that, let's pass in Glorp. And then this thing takes in a character, does a little switch class, prints out this one, prints out all of this stuff. If there is a mentor, it does this. Oh, well, we don't even have to do anything, right? I didn't even have to do anything. That was easy, right? That was easy. Okay, so this makes sense, though. For those that don't understand, this is, okay, so in Zig, I really wish this was the case. Anyways, if this thing is a nullable, right, then this thing is a character. Tell me that's not awesome. Tell me that is not sweet, right? You know what it's not? It's not this. If let some mentor equals c.mentor, or even worse, match c.mentor. Right? It's clean, it's small, it's nice. It's the nicest form. Yeah, it is awesome. For those that have done enough, it's nice. It's nice. Oh, you're right. What color scheme are we using? You're right. What am I doing? Tokyo. Okay, was that too much? No? Okay, good. I'm still yelling. Even if they said that was too much, what am I saying? I'm still going to do it. Falky. Oh, my boy Falky. Oh, Falky. I love Falky. Okay, I literally love Falky. Okay. Installation. Let's do it. Falky. Oh, Falky. Oh, Falky. Let's go to dev. Let's actually go to Neovim. Vim it up. Colors. Yep, I like it. I like it. I like it. I like it. I don't know what priority is. I don't care about priority. Let's go like this. Oh, wrong language. Hold on, Tokyo night. Tokyo night. Night. Tokyo night night. Got him. Okay, okay, okay. So there we go. So we should have Tokyo up. Hey guys, why not from home? I'm in Brazil. That's very detailed roadmap. You're a detailed roadmap. Do you like my roadmap? I like it. I think I'm going to drop Ansible. Honestly, I think I'm dropping Ansible for my local work dev, and I think I'm just going to go with a pile of install scripts. Because the copying over of dev end takes so effing long, and it's super annoying. What the hell is things called? I just want fast copy. Yeah. Yeah, let's do that. All right, we're on a quiz, boys. Boys, we're on a quiz. We're on a quiz. You don't have to use all of Ansible. You can use Ansible. Wait, what is that? Ansible. That file is pretty fly. Yeah. I'm doing Brazil time. Okay, elephants. Elephants walking along the trails are holding hands by holding tails. From holding hands, Lenore M. Link. Well, thank you, Lenore. But I don't care, okay? This is a singly linked list. We're doing a singly linked list, boys. Singly linked list. Uh-oh. Don't we need this thing to be nullable? Don't we need... first off, doesn't this thing need to be a nullable? This feels a little... I personally worry having a non-nullable one. Okay. Worries me. All right, elephant A, elephant B. Let's go like this. Visited. It must zero out memory. Is that what's happening? I can't tell what's happening. I feel like that needs to happen. What's this thing? Let's see. Wait, what's happening here? Where's... Oh, there's no B? Oh, please add elephant B. Oh. Okay, I mean, that's not really an impressive feat here. Okay. Nice. The problem is once you visit, you can never revisit the elephants again. This is not very good. Oh, right. Okay, so they actually don't want that. They actually expect this to be a complete list. Ooh, we're getting into optionals. Let's go. There we go. Easy. Okay. I don't really understand the optionals and pointers quite yet. You'll visit this exercise later. Yeah. Awesome. I think you have a Rose Pine before, not Tokyo Night. Yes, I did. Nice job. Visit was preset to false, so you didn't have to set it. Oh, really? Okay. Oh, because you can set... Oh, my goodness. You can set default values. The language is awesome. The language is awesome. This language is awesome. Is there a reason why Primogen don't use VS Code? Yeah, because I don't like VS Code. It's that easy. Why? Here, can I invert the question? Why would you use VS Code? Someone give me an answer right now. I'm not seeing a lot of I'm not seeing a lot of it's really fast. Yeah, that's not really fast. Because it's widespread and free. No one gave me a good reason. Except for that one. Really easy to set up extensions. There you go. That's probably the only really valid reason, is that I can click buttons with my mouse to set it up, and I don't want to do any sort of customizing other than extensions. Right? Because I have the same extensions you have. Right? Mine just took a little bit more to set up. That's all. What's a mouse? A mouse is something I believe you store in your balls. I don't know. All right, 45, optionals. Let's go. Sometimes you know that variables might hold a value or might not. Zig has a neat way of expressing this idea called optionals. An optional type has a question mark like this. Now, foo can store either a U32 int or null, a value storing a cosmic horror of a value not existing. Understandable. If foo equals null, begin screaming. Before we can use the optional value as a non-null type, let's say a U32 integer in this case, we need to guarantee that it isn't null. One way to do this is to threaten it with the or else operator. Oh, nice. Foo or else 2. Okay, I like it. Here, bar will either be equal to a U32 value or else 2. Okay, nice. Hey, you know what? I like that. Deep thought. Let's see. Please threaten the result to answer that. Let's see. Or else 42. Oh, nice. That's kind of cool. That's cool. Okay, I like it. I like it. Now that we have optional types, we can apply them to structs. The last time we checked it in with our elephants, we had to link all three of them together in a circle so that the last tail linked to the first elephant. This is because we have no concept of a tail that didn't point to another elephant. Yes, we can also introduce the ooh. Oh, so there's unwrap. Nice. Oh, there's unwrap. Let's go. Hey, detorque. Detorque. Thank you. Detorque. Detorque. Thank you. Hey, by the way, if I missed anybody, I'm sorry. Hey, typical lunchbox. Thank you for that tier 1, baby. Let's go. Primogen's lost cousin. Hey, will you come again to the in the future to Brazil? I don't know. Monkey programmer. Thank you for that tier 1, baby cakes. I appreciate that. And Phantom. Thank you again. Thanks, Elijah. One more time. All right. You know, I'd never unwrap. Yeah, you do. Yeah, you do. Bookworms, thank you. Is the same as constant foo or else unreachable. See if you can find it. Let's see. See if you can find where we use this shortcut below. Let's make our elephant tail optional. Okay, so we have an optional tail, right? And we set up these references, and then we visit tail, which we then use this one. If tail equals null, we should stop once we encounter a tail that does not point to another elephant. Yes. But why do that? Right? Should we just go like this? Oh, no, because it doesn't break, right? Oh, yeah, I guess you could. Right? Would you do something like that? Is that what you do? Or I think they go like this. Huh. Okay. Tail or else break. Oh, interesting. Yeah, I wonder if you could do that. Or else break. Okay, that's cool. That's cool. That's super cool. Okay, that's super cool. Because that is like a huge pain in the ass to express in a lot of languages. I like that. I like that a lot. $5 a month or exit OS. Yeah. There we go. $5 a month or exit. There we go. We got it. Pretty cool. Yeah, or else is so good. Or else was surprisingly good. Kind of weird though, like control flow assignment to a variable. Why not VS22? You do this all the time. I mean, if this were Rust, right? If this were Rust, What's the difference between that when you're working with errors? Right? Like that's what you do. You know, this one's just a little bit more verbose to say the same thing, but it's kind of nice. It's kind of nice. I like it. I'm not upset. If this were Rust, would we be here until fucking February 2025? Rust is not that hard. It's just that there's certain things about Rust that are hard. Help, evil alien creatures have hidden eggs all over the earth, and now they're starting to hatch. Before you jump into battle, you need to know these things. 1, you can attach functions to structs and other type definitions. Foo, struct. Okay, foo, struct, hello. Okay, interesting. I think I like the Rust/Go way of doing this, where you don't put your functions inside the definition. I personally think that that's much better. I wonder if you can do that, but I just think it's better. I just hands down think it's better. A function that is a member of a struct is namespaced within that struct, and and is called by specifying namespace and then using dot syntax. Okay, easy. Oh, okay, that's on the struct itself. Oh, that's like a static function. Okay, so in Rust, that would be this. Right? Okay. It's Diego. Thank you for that tier 1. Let's go. Right? Okay, so that's the same thing there. Let's see, neat. A neat feature of those functions is that their first argument is an instance of the struct or pointer to one. Then we can use the instance as a namespace instead of the type. Okay. Nice. Okay, cool. I like it. Notice that some of the name, Notice that the name of the parameter doesn't matter. Just use, some use self, others use lowercase version of the same type, but feel free to use whatever is most appropriate. Okay, you're armed. Please zap the aliens. Okay, we got this, baby. We're gonna do it. Okay, so we got this one. My guess is that, look at this alien. Look at this hideous alien struct. Know your enemy. We hate this method. I do too. So I'm assuming we're gonna want this. We're going to want alien is going to be a reference to alien, right? Is my guess. Oh, maybe we don't want to do anything to that. Before I do that, let me read this. See, your trusty weapon, zap those aliens. It's a damage. It's a heat ray. We love this method. Zap, heat ray, alien, cause damage. Okay. We have a bunch of aliens right here. Aliens alive equals length, heat ray equals damage 7. While aliens alive is greater than 0, aliens alive equals 0. For aliens. Okay, so that means we can go. Do I have heat ray? I do. Heat ray dot zap. Then I just go. What is that? I don't understand what that syntax does. Yeah. I think that's... Hold on. Expected type, 47 methods found constant pointer. It's a const pointer? Hold on. What the heck is this about? Okay. Aliens is a var. This is a... I'm confused as to why that is. Why is that a const pointer? Oh, does this... Does that make it into... Does that make it in... Oh, read the comments. Loop through every alien by referencing. Let's see. Star makes it a pointer capture value. Okay, yeah, but we have a pointer capture value. I'm missing which one it is. Right? Because that, I mean, I shouldn't have to do anything there, right? That doesn't make any sense. Wait. Did we even change anything? Did I even change anything? Oh, I just changed that. Oh. I'm confused by this syntax. The autocomplete sucks. The autocomplete sucks because look what it's saying it is. It says it's an alien, but it's actually not an alien. It's a dot star alien, right? Right? Isn't it modify? I can't remember what it is. But it's an alien. Yeah, the capture value is const by default. So to modify, you need a pointer. Yeah, but the problem is that it doesn't show its type properly, right? It just shows it as an alien. That's why I was confused because when I highlighted it, it said alien, so I naturally went like that. You know what I mean? LSP not great. Yeah, my boy alien is a star. Yeah, I know. It has a star in there. All right, so we got 48. Now that we've seen how methods work, let's see if we can help our elephants out a bit more with some of the elephant methods. We got tail visited, pub get tail. Remember, this means or else unreachable. Okay, that seems crazy. This actually seems crazy. Has had. Do we need to do that? Can I just go? Okay, that'd be crazy if I had to do that. Visit. Okay, that edited it. Okay, so then we do this, we do that, we go and visit elephants, and we go print, visit. Wouldn't we only have to like this? E dot. Isn't that all we'd have to do? Because that's just going to destroy everything. Okay, okay. Am I missing something? Oh, hold on. New method, get tail, right? Has tail. This thing's a circle anyway, so it doesn't really matter. And we want to keep going until we visit something, right? Wait. Zig's enums also have methods. Oh. Oh, really? Hey, thank you, Yakira. Yakira, okay. I appreciate that. Thank you. Let's go. Who was the other person? Thank you, Radius. Hey, keep up the great content, Brian. We're trying. We're just working through Ziglings. It's pretty fun. Ziglings is a great way to learn. All right, so we have an enum. Okay, so it's like Java style enums. Okay. Couldn't they just do a, oh, I guess they're doing it. Couldn't they just do an else here instead of having to go through all the other ones? Interesting. Okay. So it's like Java style enums right there. I really like that they have Java style enums because I also know they have unions of some sort. So having a Java style enums else is generally discouraged. Okay, that makes sense because it doesn't capture it in compile time, right, T? Is that pretty much it? You have a mouse in your hand? I do. Is that why? Because then when you compile and you make a change, it doesn't... I assume that's why. Yes, okay. I thought the mouse belongs in the ball. They do. Put them in the ball. All right, so I'm confused to the point of the exercise that I'm on. I think I did it correctly. Oh, 48. Let's see. Oh, it's not a circle. It's not a circle. Oh. 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 Oh, they wanted me to use this. Right. I don't really want to program like that, but that's fine. Feels kind of silly to program like that, right? You would think it'd have something. I mean, it just feels silly to program like that. Oh, the balls, yeah. I believe you can do zig test file name. Oh, to test a single file. Yeah, but then I'd have to know the file that I'm on. Okay. All right, we're on a quiz. We're on a quiz, boys. Trunks and tails are handy things from Folding Hands. Let's see, from Folding Hands by Lenore. Now that we have tails all figured out, can you implement trunks? All right, trunk. Okay, yeah, this is a doubly linked list here, people. We're going hard on the doubly linked list. Get tail, has tail. All right, so I guess I'm supposed to copy these things and effectively hit the word tail with head, and then do it again, except for a tail with head, right? I assume that's what they want. Tail equals this. Oh, trunk. Oh, I did head. Trunk, let's go trunk. There we go. Yep, all right, so we do that one. If tail does this, break, ugh. Let's see, follow trunks, has trunk, do this, break. Oh, interesting, so it's also doing the exact same thing. Okay, so that should do everything? Yeah, okay. Nailed it. Nailed it. Highlighted message. Well, thank you. You did what? I got my head all confused. What is he doing, guys? Project or example. We're doing zig links. We're learning zig. It's on the stream. It's right there. We're learning zig. We're trying to learn zig, people. I don't know anything about zig. I don't know anything about it, so I'm just trying to learn. I'm just trying to get my keyboard wet. Okay? Did we abandon Groovebox already? Yes. Better question is why zig? Better question is when am I going to go to another meat house? No value zig. Okay, so let's go to number 50. All right, we live in placid island of ignorance in the midst of black seas of infinity, and it was not meant that we should voyage far. Okay. Zig has at least 4 ways of expressing no value. Undefined. Undefined should be thought of as a value, but as a way of telling the compiler that you are not assigning a value yet. Any type may be set to undefined, but attempting to read or use the value is always a mistake. Okay, that makes sense, right? You're going to define it later, and that's that. Null. Null is a primitive value, is a value that means no value. This is typically used within optional types. Yep, okay. Error. Errors are very similar to nulls. They are a value, but they usually indicate that the real value you were looking for does not exist. Instead, you have an error. Okay. Okay, and void. Void is a type. Let's see, is a type, not a value. It is the most popular of the 0-bit types. Okay, so this would be like the unit, right? Those types which take up absolutely no space and have only have semantic value. When compiled to the executable code, 0-bit types generate no code at all. Okay. Zig has all these ways of expressing different types of no value because they each serve a purpose briefly. Okay, please use the correct no value here. Okay, so if we do a const right here, I guess technically I could do a null here. Right? This one I could do an or constant. I guess I could do an undefined. Right? I could do that. Print second line. Print second line is going to be an optional concept, so I can do that. Oh, I can't use a null here. I'd have to use an undefined here. Here, I'd have to use what? How do I express an error? Is that what I want? Maybe? Print the second line. The second line is going to be this thing, so you need null. Second line, even may die. Okay. And then this thing is a void. Yeah, I think that's right. First try with feelings prime. Cthulhu. Did you write your resume in Vim? What's a resume? All right. I have thought, let's see, if you thought the last exercise was a deep dive, no, it wasn't. Shouting, down here, bits and bytes flow from RAM to the CPU like a hot, dense fluid. Forces are incredible. But how does all of this relate to any data in our Zig programs? Let's head back up to the text editor and find out. That's better. Now, can we look at something, let's see, some familiar Zig code. Import adds an imported code into your, to your own. In this case, code from the standard library is added to your program and compiled with it. All of these will be loaded into RAM when it runs. Oh, and that thing that's named const as standard, that's a struct. Okay. Oh, so it's returning a struct from a module. Okay, so you always use structs. Interesting. I wonder what that looks like to program. Huh. I've been trying to do Zig to write a JPEG decoder, Huffman trees. Oh, really? Okay, well, I'm about to do Huffman. Okay. Remember our old RPG character struct? A struct is really just a very convenient way to deal with memory. These fields, gold, health, experience, are all values of a particular size. Yeah? So we can have gold, health, experience. Yeah. So that's a character. All right. Here we create a character called the narrator that is constant, constant immutable instance of the character struct. It is stored in your program as data. And like instructive code, it is loaded into RAM when your program runs. The relative location of this data in memory is hard-coded, and neither the address nor the value changes. Okay. The global wizard is a character. Let's see. A character is very similar. The address for this data won't change, but the data itself can, since it's a var. Okay. A function is an instruction code to a particular address. Function parameters in Zig are always immutable. They are stored in the stack. A stack is a type of data structure, and the stack is a specific bit of RAM reserved for your program. The CPU has special support for adding and removing things from the stack, so it is extremely efficient place to store for memory storage. Also, when a function executes, the input arguments are often loaded into the beating heart of the CPU itself in registers. Our main function has no input parameters, but it will always have a stack entry called a frame. Yes. Let's see here, glorp character will be allocated to the stack because each instance of glorp is mutable and therefore unique to the invocation of this function. Yep. Okay. Cool. Even reward XP value is interesting. It's not. It's an immutable value. So let's see. So though it is local, it can be put into the global data and shared between all invocations. Oh, interesting. But being such a small value, it may also simply be inlined as a literal in your a literal value in your instruction code where it is used. Interesting. It's up to the compiler. That makes sense. Now let's circle back to the S standard struct we've imported at the top. Since we just used regular Zig value, once it's imported, we can also assign new names for its fields and declarations. Debug refers to another struct, and print is a public function that namespace within that struct. Let's assign standard debug print function to a const. Oh, okay. Okay, cool. Okay. Now let's see. Now let's look at the assigning and pointing to the values in Zig. We'll try 3 different ways of making a new name to access our glorp character and change one of its values. Glorp1 is incorrectly named. We asked Zig to set aside memory for another character struct. So when we assign glorp to glorp1 or glorp access 1 here, we are actually assigning all the fields to make a copy. Oh, does this make a copy? Hold on. So is this C, that's like C style, right? Is that it's by value? Oh, okay. That one is such a gotcha. I have always hated that's one thing I've always liked about Rust is that the default characteristic is a move. I always think a move was the right decision there. Because a copy just feels funny to me. It makes sense. I know. It just never felt like it made sense for me. Brazil mentioned, absolutely. How's Brazilian water? Delicious. The right decision is always JS. Oh, really? That's a weird decision, buddy. All right, so this makes this. So this is a glorp access. We change it and it doesn't do anything, right? That would be false. Am I supposed to fix it? You don't need to fix this, but notice that when it gets printed in your program's output, yeah, it'll be false. Note, let's see, if we tried to do this with a const character instead of a var, changing the gold field would give us a compiler error. All right, so this is a glorp2 access will actually change the stuff. Okay. Glorp3, oh my goodness, I gotta quit touching the mouse. Glorp3 access is interesting. It's also a pointer, but it's a const. Won't that disallow changing the gold value? No, because it's a pointer to a constant. As you may recall from our earlier pointer experiments, a constant pointer, they really need to rename this. It's not a constant pointer, it's a pointer to a constant. I really dislike when they, does anyone else? Is that just me? Am I being too specific? A const pointer is a pointer that can't change. A pointer const is a pointer to a constant. Right? No, you're right. Yeah. I think they just got it wrong. I don't know what this is, Chase TV. I'm on my Linux machine, so I don't even know what you're asking. What do you mean it's exploding? A const pointer is a pointer that cannot change, but the value can change. Yeah. Yeah. You're reading it backwards. Yeah, you should know. No, you should always read it forwards. You should always read it straight forward. It should always copy. Yes, I agree with that. Andrew also wanted to change const to being to let. Why? I don't get that either. I mean, I think that it's perfectly fine. I do like actually const is a pointer. I think that's great, and I also think var. I think this is a great way to do it because you're being explicit. This is a constant pointer to something. I like the C semantics. I think C got it right on that. I think C has it correct, which is either it's a constant pointer to a constant, or a pointer to a constant, or just a pointer. Right? It should be a const pointer, not a I'm not talking about pointers. Oh, you're talking about const let. It already says constant pointer. I know, but that's wrong. A constant pointer, it would be this, right? The problem is earlier pointer to, right here. See, they do this whole constant pointers. Wait, hold on. Where is it? Pointers 3. They're using funny terms for it. They're using funny terms in here that I got super confused by. Maybe I just got confused by it, and it's actually not a problem. Is this a pointer constant? Okay, so this is a const pointer. This is actually a const pointer. Am I reading this correct? Okay, this is a const pointer that can't change what it's pointing at. Okay, so maybe they are using it correct. Maybe I got confused by their language, and I was actually the bad one. Okay, I'm the bad one. All right, note, if we tried to do this with a pointer constant character pointer, that would not work, as we get a compiler. Yeah. Moving on. When arguments are passed to a function, they're always passed as a constant within the function, regardless of how they were declared in the calling function. Oh, okay. I'm generally fine with that. I'm fine with not being able to change arguments. I think that's probably always a good plan. All right. Knowing this, see if we can make level up work as expected. Okay, well, that's just... Right? All right, there's more. Let's see, there's more. Data segments allocated at compile time and the stack allocated at runtime aren't the only places where program data can be stored in memory. There's just the most efficient. Sometimes we don't know how much memory our program will need until the program is running. Also, there is a limit to the stack size. Let's see. All right, these are heaps. We're talking about heaps now. You can use as much heap memory as you'd like within physical limitations, of course, but it's much less efficient. Is it even within? Yeah, I guess physical limitations of what, your hard drive, or of the bit space. You're in Brazil, Indiana right now. No. I'm in Sao Paulo. Sao Paulo. Thank you, Pete Copley. Let's go. Sao Paulo. Did I spell it wrong? I did. Washed. Appreciate that, Twitch Prime. Oh, hey, Prime. Just sorry to bother you with this. I'm not sure if you've already heard, but there's a major disaster happening in the southern region of Brazil. I have. There's a lot of stuff. I've seen that. Yeah. I've seen a lot of this. Yeah. I'm not going to go to LinkedIn. I don't go to LinkedIn. LinkedIn is a weird place, but yes, I've seen it all over Twitter and stuff. It's very sad. It's crazy. It is quite wild. There's a people here who, like, I was supposed to meet up with somebody today or tomorrow that no longer can come because 20 of their employees' houses just disappeared. Just like was and is not anymore. Prime, do you experience neck pain from working on a computer? No, typically I'm looking up right here. So typically I'd be programming like this, which avoids neck pain. But I'm doing this right now, so yeah. So I'm definitely going to probably get like neck discomfort. Never use your laptop if you can avoid it. People that use their laptops for full-time programming are pretty much young. You're less than 30, right? That's all it is. It's like, hey, less than 30 guy. Demon, I appreciate that. I watched a video where you recommended crafting interpreters. No, I didn't. I've never recommended crafting interpreters. I recommended the interpreter book. Right? Do the Thor voice. Do the Thor voice. Yeah, just keep moving your posture. That's the name of the book. No, it's the interpreter book. This is the one that I always recommend, which is different. It's in Go. The crafting interpreter is a different book, right? Don't you use this? I'm using a System 76 laptop right now, yeah. So if I go like this, if you go book, you'll see right here. I don't get anything out of this. It's interpreter book. The best posture is your next posture. I'm not sure about that. I don't know if that's true. Is it the one in Java? So that'd be crafting interpreters is the one in Java. Where are you? WeWork? I'm at a WeWork place, yeah. All right. You can use as much heap memory as you'd like. Yeah. But it's much less efficient to manage because there's no built-in CPU support for adding and removing items, as which we have for the stack. Also, depending on the type of allocation your program may have to do expensive work to manage the use of the heap memory. We'll learn about heap allocators later. I hope we get to like build a small one ourselves because that'd be fun. Whew. This is a lot of information. You'll be pleased to know that the next exercise gets us back to learning Zig. Awesome. Okay. Cool. All right, slices. Oh, okay, 52. This is very. We're in a good spot here. What's 53? 53 is more slices. 54 is many pointers. 55 is unions. 56 is unions 2. 57 is unions 3. Then we're at quiz. Nice. Okay, so we're getting into the major language features at this point. Did you hear that TJ has a bigger discount than me? He's bigger. He has many things that are bigger, just not height. The interpreter book, right here. This is what I personally recommend this one because I've been through it. I can't say they're all. Got him. Yeah. Got him good. Hey, thanks for the hype train, everybody. I appreciate that. Hey, Rattler, thank you for the tier 1. Let's go. Well, let's see. What are you working on now? Just the Zig. It's called Ziglings. Okay, so I'm happy with where we got today. This was good. We'll do some more learning. Hey, Infinite Me. I just did that. Anyways, I'm very happy about where we got for the Zig stuff. I'm very happy because I'm liking Zig, but this is gonna be the end for Zig time.